Let me also show you how my website works. Can you see that okay?
Yes, yes.
I don't know if you've had a chance to visit this or not. It's algebra2calculustutor.com.
Okay.
This will give you more information about me, background, references. Notice also on there where it says schedule appointments. If I click on that,
Okay.
you can schedule all of your appointments by going to my website and clicking on this, and it then proceeds to give you all of my available openings and lets you schedule an appointment on my website without talking to me.
Okay.
Which is pretty cool for people that it's pretty hard sometimes to get our schedules matched up. Most kids have a lot of after-school activities, and that's my busiest time of the week, also from about 3 o'clock to 8 o'clock. But I do tutor on the weekends if you're interested in that also.
Okay, and that may be a good option for her as well.
Yeah. Also on here, I have numerous sample sessions that are recordings of online sessions. You can see I have an algebra, a trig, a calculus, ACT prep, geometry, and each one of these are maybe 3 to 5 minutes. Gives you a chance to look at it, see what the online. Of course, you're looking at that now, so you don't really need that. But okay.
No, it's good to know where to find it.
Yeah. So let's go back to the whiteboard. And Grace, if you have some problems you'd like to look at or give me verbally, I'll write them here and we'll work through them, and you can get a little bit of idea about my teaching style.
Okay. One of the things that we're currently doing in my math class, it's called LSRL. It's like the least straight regression line or something like that.
Okay. Linear regression? Mm-hmm.
Yeah. And then we're doing correlation coefficients, and everything from LSRL, the stuff that we're doing now is building off of that, and I still don't really understand how to do the LSRL.
If I draw an XY coordinate plane like that, where this is the x-axis and this is the y-axis, and I put a bunch of data points on there. Let's say that I have an x value of 2 and a y value of 2. And then I have another data point up here, maybe an x value of 4 and a y value of 5. And another data point up there. And let's put points of 9, 10 on those. So I've got 3 points here that look like they're pretty close to a straight line, but not exactly. So what this does is it puts a line of least fit through those 3 points. And that's exactly what linear regression is the line that results when you fit the most perfect line you can fit for those 3 points. In other words, it wouldn't be this, right?
Right.
It wouldn't be this, but the question is where is it? It doesn't necessarily go from there through there because that's pretty far away from that point, the middle point. So sometimes it would be just the line that best fits, and there's a very complicated mathematical way to figure that out, but if you put it into a calculator, you'll get the line of least fit, or linear regression, and the correlation coefficient that you talk about. This particular set of 3 points and this line are correlated pretty nicely.
Right.
But what if my points were there, and there, and there? Now, if I try to draw a straight line between all of those,
there's a lot of outliers.
Well, there's a lot of distance. Basically, your correlation factor is the sum of all the squares of all of these distances. So the further they are away from the line, the lower the correlation is going to be. And your correlation is measured from 0 to 1. In other words, 0 correlation is no correlation, basically. A correlation of 1 is perfect correlation. In other words, if I'm looking for a correlation of 1, I would have probably a bunch of points that are all exactly in a straight line.
Right.
Then when I put the line that goes through there, I got no distance between each point and the line, perfect correlation.
Okay.
Now that's pretty sophisticated stuff for algebra class.
Yeah, it's definitely a lot different because the year before us, they didn't even have to do the stuff that we're doing right now. So
No,
I don't really
I'm
understand
actually surprised you're getting it in Algebra 1.
Yeah.
And do you have a calculator, a TI-84 or a TI-Inspire?
Yeah, I have a graphing calculator.
Which one is it, do you know? Is it the
It's
TI-84?
TI-83.
83? Okay. Which is
Yeah.
fine. They haven't made you get the new Inspire CX yet, huh?
Well, yeah, I don't have all those new fangled ones with
Okay.
all the lights and stuff.
Well, you can do linear regression on the TI-83 also. And
Right.
what it ends up giving you is the line defined as y equals mx plus b. You familiar with that?
Yeah.
And then it gives you r, and it gives you r squared.
Yeah.
And r squared is just maybe a little more accurate measurement of the accuracy of the line. Obviously, if r is less than 1, r squared is going to be even more less than 1. In other words, if r were pretty good fit, equal to 0.9, well, r squared is equal to 0.81. So when you square a number less than 1, it gets smaller. So r squared is almost always going to be less than r.
Okay.
But it doesn't really matter. The r squared or the r is a measure of correlation.
Right. Because what we learned in class today was she said to write down that correlation coefficient is a measure of how much or how little data is scattered around the LSRL. And
Right.
she also had us write down r squared percent of the variability in the dependent variable can be explained by a linear relationship with the independent variable.
Okay. So the independent variable is x, and y is the dependent variable.
Okay.
Okay. They're probably not going to ask you too many specific problems around this concept, just because it's difficult to structure a question, other than giving you a table of x and y points and saying, come up with the LSRL for that. And
Right.
you could only do that in your calculator. In other words,
Okay.
I'm not sure I know how to do it manually. You basically take the distance from the line and square all of these and then add them all up. And that has something to do with calculating it. But nobody does it by hand. They all do it in the calculator. So
Right.
that would be the only problem, would be if they gave you a table of XY values like this.
Yeah, I actually have a problem that I'm looking up right now that has x and y values.
Okay. Unfortunately, I have a TI-84, but it ran out of batteries about 1.5 years ago, and it hasn't worked since then. And I ended up upgrading to the TI-Inspire, the CX, which is
Okay.
a much nicer calculator and cheaper, actually. So I don't know how to do linear regression on the TI-83.
Okay.
I know how to do it on the Inspire, but that doesn't do you any good. Do you know how to do it? Do you know how to make a table and make a list? I know conceptually how you do it. You have to make list 1 and list 2.
Right. And I looked up a YouTube video for it, and I actually wrote down step by step because this older woman went through like step by step how to do it, and she showed it, and I wrote it down. I don't understand. I don't understand like
You've already
mastered.
You've already mastered the art of learning. Which is go to YouTube.
Yeah.
And I'm being dead serious. Especially for difficult calculator questions. I mean, if I knew how to do it, I would tell you instantly. I kind of remember you make a list 1 and a list 2. That's your X variables and your Y variables.
Right.
Then I think you go to a key, the VARS key, V-A-R-S.
Yeah.
And that presents you with an option to do a linear regression based on your 2 lists. In other words, if I made a list here, 3, 5, 8, 9, 10, that would be my X list, or L1, and maybe L2 would be 1, 4, 10, 15, 19. So now I have my L1 list and my L2 list, and you want a linear regression of the format y equals mx plus b between those 2 lists. And linear regression isn't the only kind you can do. You can do quadratic regression, you can do exponential regression. In other words, yeah.
She just touched base about quadratic regression today, so
well,
we're just now learning that.
If I had a bunch of points like this, linear regression doesn't look right.
Right.
In other words, it looks like a linear regression would have an R of 0, almost. But if I do a quadratic regression almost fits perfect between those points. So a quadratic regression would have a very high R for this case. But that's what the other options in your calculator are, is why you have linear, quadratic, exponential, and others. But that's basically it. I wouldn't think you'd get a whole lot more on this topic other than what you have right now.
Yeah. So the LSRL is just how do you find the distance between the points and the line of best fit?
What do you call it? RSRL?
LSRL.
Oh, that's what I thought you said the first time. Yeah.
Yeah, that's what I said. But like I don't.
How do you find what? How do you find what?
But the point, like the distance between the line of best fit, which is I guess you call that the.
You don't.
You don't?
That's not the trick. The trick is to put in your table of points. In other words, these points would correspond to a point there, maybe a point there, maybe a point there, a point there, and a point there. That would equal that table. Okay? So then the calculator figures out the line of best fit for those points.
Right.
And it gives you the answer back as y equals mx plus b. That's the equation of that line of best fit for those points. And it also gives you an r and an r squared, which is a measurement of how well that line fits those points.
Okay.
So you don't have to do this other stuff manually, ever. I've never known anybody had to do it manually. So I might be wrong, but I would not think that that's part of your Algebra 1 curriculum.
No, that makes
understanding how to come about with this line is, in other words, but they're always going to give you a table which you put into 2 lists, and then you ask the calculator to tell you what the line of best fit is. Linear. This L must stand for linear. This or one of them stands for line and one of them stands for linear. This is regression. What's the S stand for? Squares?
Least
Squares, regression line, maybe?
yeah, that's what it is.
Okay.
Or yeah.
Yeah, I'm actually not familiar with that four-letter expression. I've always called it the linear regression or line of least fit, or line of best fit.
And let's see. Residuals. No, we don't need residuals. Let's see my homework. So the correlation coefficient is just what the calculator says for the R squared?
Yes.
Okay.
I'm not 100% sure whether it's the R or the R squared. I think the R squared is the correlation coefficient.
Right.
But yeah, the calculator is going to spit back what M is, what B is. So that's the equation of the line. And then it's going to give you an R and an R squared.
Okay.
Those four things.
If she continues on in algebra, what was that calculator that you said that you have that's probably a better value?
It's called the TI Inspire CX. It's $130.
Okay.
And it is quite a bit better than the TI-83.
Okay. Probably invest in something like that.
Well, yeah, in fact, out here, they're insisting that all freshmen get it. Even if you have an older sibling. I have a sibling, a couple of students who are siblings, and the older student has the TI-84, and they still made the younger student buy the Inspire. So the Inspire is definitely the calculator of the future.
Okay.
Yeah, all the girls at my table in my algebra class, they have, it looks like a TI-83, but it's, the screen is a lot more lit up, and like
that sounds like the Inspire. Yeah.
Yeah, that they have those.
And it'll do amazing things. It'll factor, it'll do complete the square, it'll expand, it'll do everything that we spend 6 months teaching students how to do. So they won't let you use certain features of it when you go to take the ACT and SAT. That's how good it is. They have to shut off certain features in order to use it on those tests. Yeah, because factoring is a big part of those tests.
Okay.
Okay. Do you have any other kinds of algebra problems that, like factoring or factoring a quadratic, something like that? What kind of stuff are you working on besides this linear regression stuff?
Well, for one of the problems of my homework, it's asking, it says Marissa calculated the least square, that's what it is, the least squares regression line. A equals -14 plus 0.41 t, and A is the attendance in thousands, and T is the high temperature in Fahrenheit that day. And then it says interpret the slope in this context. So I'm not real sure what to do with that.
The slope is going to be the change in
the rate of change.
The rate of change of the temperature but relative to time. Your horizontal axis is time?
No, the horizontal is temperature, and then the vertical is residuals in thousands of people.
Oh, okay. I don't know what residuals mean. What do you mean?
It says a residual plot is created in order to analyze the appropriateness of a best fit model.
Okay.
A residual plot has an x-axis that is the same as the independent variable for the data.
Okay. And the y-axis is the dependent variable.
Yes.
Okay. So is all they're talking about is you have a chart that looks like this. What axis is, do they give you the information about what you're comparing?
Yeah, temperature is the x-axis.
Okay.
And then it goes like up to 100, but I mean,
Uh-huh.
yeah. And then the y-axis is residuals by thousands of people.
Whatever that means. I'm not sure what that means. A residual, and the answer is in thousands?
Yeah, it just says, it says like parenthesis 100s of people, parenthesis. So yeah, that's...
In thousands. Okay. In other
Yeah.
words, if we have a temperature of, say, 20, we have some number of residuals?
Yeah.
Okay. So, in other words, we're going to have a table that we can write that have these values for x and y. In other words, whatever the value is, the coordinates on that point right there, put that for x and for y. And then the way you come up with the line of best fit is to put those two lists into your calculator and request your calculator give you the line.
Okay.
That's how you do these.
All right.
Now, as far as the meaning of the slope, let's say the line it gives you is that. Well, the slope of that is the change in residuals versus the change in temperature. That's the meaning of it.
Right. Okay.
Whatever residuals mean, I'm not sure. I have no idea what temperature would be related to residuals. Residuals. Huh. All right. I don't need to know. That's all right. But
Okay.
all of these problems are the same way. You need to put in a list, at least 2 columns, always 2 columns, I guess, into your calculator, and then request that the calculator give you the equation of the line based on those data points.
Okay. And that's the LSRL.
Uh-huh. The line, the least square regression line, or the line of square regression linear. No, it's the least square regression line.
Regression line. Yeah, that's what it is.
Okay.
Okay.
Have you gotten to, what other kind of stuff are you doing in algebra besides linear regression?
Recursive sequences.
Okay.
They have, okay, yeah, this is, oh goodness.
Arithmetic sequences?
I think so, yeah. There's like A1 equals 5, and then, it's strange. It says AN equals, AN minus 1.
Or is that a negative one?
Or, is that a negative 1?
Like that?
Crap.
Yeah, that's right. He's got it. Right
Yeah,
there.
perfect. And then it says plus 6, like right after that.
What that means is that, let's first of all talk about sequences. If I give you a sequence like this, a sequence is merely a succession of numbers. This is an arithmetic sequence because each term is separated by the same amount, 3. So this is said to have a common difference of 3.
Yes.
Okay? So if I want the normal expression for the nth term, it would be the first term plus the common difference times n minus 1.
Oh boy.
Well, that's the normal expression of a sequence. That's not the recursive. This is the recursive. The definition, this is the explicit. The definition of recursive is that it is defined as the term previous. In other words, this definition over here is defined as the first term, the common difference, and the number of your term. This over here is defined completely as the previous term plus some number.
Okay, so this is just like T of n. Are you familiar with that?
Yeah. In other words, if I wanted to express this sequence that I've written right here, the explicit way would be the first term plus the common difference times n minus 1. So if I wanted to know the fourth term, so a sub 4, that's equal to 2 plus 3 times 4 minus 1 is equal to 11. So it is. If I wanted to know the 40th term, I could figure it out pretty easily using this equation. Whereas if I look at the recursive definition of it, this one over here that you gave me, notice that this is the common difference, always, in the recursive definition of an arithmetic sequence. If I wanted to know the fourth term, well, I'd have to know the third term.
Right.
And add 6 to it. Well, I don't know the third term. So this is actually a superior definition depending on what information you know. As long as you know the first term and the common difference, this will always allow you to figure out the nth term. If you know the previous term and the common difference, well then this is the one you want to use, the recursive definition.
Okay.
Okay. I tell you what, my first sessions run about a half an hour. They're free. And so why don't we call it a session for today?
Okay.
That should give you a pretty good idea of how it works. And I have recorded it, so I'm happy to send you a link to that recording just so you can see what it looks like to watch the recording. And I'll send it to that email that you used when you signed on to GoToMeeting.
Okay.
Okay. To end this thing is all you have to do is to click on the X in the upper right hand of GoToMeeting.
Okay.
That will end your GoToMeeting session. And then for future sessions, you don't have to go to that website every time. Join GoToMeeting. You'll have the program on your desktop, and just double click that icon. First thing it always asks for is the meeting ID number. What I usually do is text the meeting ID number to a student that has an online session scheduled. Rather than calling them, I just text them the meeting ID number.
Okay.
Okay? So
Yeah.
You should be all set to go. If you would like to schedule another session, I'm happy to do that now, but you can also do it on my website, like I showed you at the beginning. You can go to schedule appointments.
Mr. Cohen?
Yes.
Is it, you said, so I guess Grace I think she wrote down how much you charge, and you said I can pay for it on PayPal. So
yeah.
What are the sessions that you're charging for sessions at this point?
For a half hour, it's $16. For an hour, it's $32.
Okay. Okay, that's fine, and that's very, very much doable. So I think that I'll have her set up some future sessions with you. If
Okay.
you suggest, you think that maybe twice a week, a half an hour,
Yes.
twice a week is probably...
I think that's better than 1 hour a week. I do.
Okay. Okay.
Great. What's your last name? What's the R stand for?
Radliff. It's RADLIFF.
Okay. Okay. I'll know to look for it. When you schedule a session, I always get a text to my phone telling me who scheduled it, so
Okay.
I'll know it's you.
And I have a different last name, but I'm sure I'll try to make some kind of notation in PayPal so that we can...
Okay.
make sure
What is your name?
My last name is Elzy. It's ELZI.
And what's your first
Z
name?
is in zebra.
Okay. And what's your first name?
Dawn?
Dawn, D-A-W-N?
Correct, sir.
Okay. And this phone number, 916-9172, is that Gracie's cell?
Yes, it is, and I'll fix it so that she can get text messages from you.
Okay. Sounds good. Well, it was nice meeting you online, and look forward to working with her.
Great. Thank you, Mr. Cohn, for your time. I appreciate how convenient this is for her and you, and how easy you kind of make it. So
Yeah, thank you.
Okay. Nice talking to you. Have a good day.
You too.
Bye-bye.